Hello guys, welcome back to my channel, Boy. So today I will be talking about pump rating. Yeah, it is actually quite similar with the two previous episodes. But before we talking about compressor, now we're talking about pump. So it's the contrary part of the compressor. In this case, I will be use pump model with this curve sample. So same with the two previous one, I have explained that in simulation we have two modes. The first one is the design mode, where we only specify the efficiency and also the pressure outlet or the discharge pressure of the pump or compressor. But now if we move into the rating mode, it means that we will have more rigorous model that use the curve of pump or compressor. Okay, so without further ado, let's do it. So now I have one stream now, water in, water at ambient condition with pressure of 1.1 bar, flow rate of 1 tons per hour, and I will add a pump here. Okay. We'll specify water arm, the energy stream by W pump. Okay. In this mode, it is enough to supply only, like for example like this. Yeah, it will converge directly because we have supplied the pressure of the outlet, or maybe usually we also specify the delta pressure or the pump head, and also we specify the efficiency. Efficiency as default is 75%, but same thing goes here. If we increase the flow rate, we have nothing changed about the pressure because it is a fixed specification from us. Okay. Yeah, or we change the fluid, it is also not changing here because we specify directly the pressure outlet. If we want to have a more rigorous simulation, we have to uh, move to the rating mode, so we will have a better response when the flow is changing or when the composition is changing. Okay, so now I will remove this 2000 and also this efficiency. Yeah, because if you look at the pump curve, the information that we have is the flow corresponding to the head and to the efficiency. So if we know the flow, we can calculate the head and also the efficiency. Okay, so now I will move to the rating tab. I will click add curve and I will paste this. First of all, make sure that the units are correct. Flow unit, head unit. Okay, and I will paste here and click submit change. Okay, and then I will give name curve speed 540 rpm, and we put this speed as 540. Okay, so if we only have one curve, it is enough. Yeah. We don't need to have anything again, and the summation directly converts. Yeah, you see that we already get the pressure of the outlet. Why? Because we only have one speed, and the pump only operate in one speed. So there's no other information needed by the simulation. Yeah, we don't need to supply what is the speed of the pump because the pump only operates in one speed. But if we add a new curve, look at the second one. One. Okay, and you see that the simulation is not converged. Why? Because we supply two speed. So at what speed this pump operates? Okay, yeah, let me add also the third one. Okay, so now we have to specify what's the speed of the pump. Okay, I will specify, for example, like one. Okay, and right now we already have our simulation converged, yeah, because we have supplied the required data. And now if we see at the plot curve, we could see the position of our operating point by this red color. Okay, maybe for the clearance, I will change the color of this to red. Yeah, so this one is the high speed, middle speed, and the low speed. Okay, so here we have this operating point, which is quite good because it is in the middle of the pump curve. It is inside the operating capacity of the pump, so it is a good one. So we can take a look what will happen if we change, for example, the flow pump. Yeah, for example, we increase the flow. Yeah, you see that the pump curve will move to the operating point will be moved to the right side. We will have more flow, but the consequence is we have less head. So it means that we have less discharge pressure. Yeah, you see that before we got to 86.3 kPa, but now we only got 255.1 kPa. Yeah, so that's according to how the pump works. Yeah, if we have more flow, we will experience less head, so less pressure at the outlet. So now I also want to have some experiment. So I will show the duty of this pump. Yeah, so right now our duty is, let me format it. Okay, three, yeah. So our power right now is 0.069 kilowatt. So now, uh, how if I change the speed into 700, but I also change this uh, into 700 RPM, like this. You could see that when I do this activity, the power will not affect. And so if you see the pressure discharge is also not affected. Why? Because here the pump is only for the pump speed is only for like indicating, or maybe yeah, for determining the head, but it will not affecting the duty or anything else. So for example, if we keep changing this into like something in 1200, but also change this curve into 1200, okay, so it will stay the same. Yeah, it will stay the same, it will not be different. I will get back to 700. So you see it's not changing. So speed is actually not a big deal in this process simulation. It's only for determining which curve should we use here. Yeah, yeah, which curve should we use, or it is in between. Uh, or if we have only a single curve, that's why we don't need to supply the speed of the pump, because yeah, it is not used for any calculations. So this is also important point for you. Okay, the last thing is I am able to change the composition here. For example, I want to make it um, to have a decade. So before that, I will also monitor the discharge pressure. Okay. Now I will change the water into decade. Okay, you could see that we will experience a different thing, yeah, because our water decade is lighter. Yeah, tissue property header density is 723. So you will experience decrease in the head. Yeah. If we go back to water, we will have more head. Okay, so that's it for the pump rating simulation. I hope it will help you to have a more rigorous simulation, and see you in the next episode. Bye bye.